Okay, good evening everyone. Bonsoir à tous et à toutes, and welcome to tonight's presentation of OTF Connects on creating a thinking math classroom with Laura Ginny Newman. We have a fairly small audience tonight, which is great. We'll be able to share and share ideas and talk to each other. We are thrilled to have people from all over the province. Let me try to show where you guys are all located. There you are. So we are thrilled to have people from all over the province, including north of Thunder Bay. And we're also obviously thrilled to have Laura with us tonight to present her subject. So at this point, I will pass the microphone to Laura and let her introduce herself, probably much better than I can do, and let her share with you her teaching approach to mathematics. So Laura, please feel free to click on your talk button to turn your microphone on, and then go ahead whenever you wish. So the class is yours now. Excellent.
Thank you very much. Good evening, everyone. I hope you had a good, healthy, productive day, and you still have some energy to continue to do some thinking this evening, because we're going to continue to look at critical thinking in the math classroom and how to create a thinking math classroom. For those of you who weren't with us last time, just very briefly, I am a critical thinking consultant, facilitator, and coach for the Critical Thinking Consortium. And the focus of my work and my passion is mathematics. And I'm really excited to be here with you this evening to continue our conversation around how engaging in quality thinking relates to supporting the use of the mathematical processes. So you can see here in session 2, we're going to be looking today and extending the learning that we did in session 1 and focusing on the teaching of critical thinking in mathematics through the processes. So last time we started to look at and we explored at how quality thinking and the mathematical processes were related. And today we're going to be taking a look at how do we go about ensuring that our students have the tools necessary for them to be proficient users of those mathematical processes, and doing that through a thinking classroom, a quality thinking classroom. So I'm hoping everybody can hear me okay. I'm just seeing that I can see everybody's hearing me. That's great. So last time, just to do a quick revisit for anybody who is new to the group, we spent some time talking about how the mathematical processes, or do the mathematical processes, promote critical thinking. And we determined how similar or different thinking critically was to thinking within the processes. And at the end of the session, the majority of people chose the far right representations to respond to the question of how similar or different these two ideas were. And for the most part, I could see that their thinking and the process of what we discussed and all the learning that was going on was fairly sound, because in the end, what we notice here, and taking right from the tips for M, mathematical processes description, we can see that the 7 mathematical processes are defined as descriptions of the actions of doing mathematics. And it's really interesting, because if we think about how do we know that we're taking the right actions or taking the actions that we need to take, we know that wise actions or effective actions can never be taken without critical thought. And we know that critical thought requires the assessing of options in light of criteria and evidence. And so if we transfer that to the idea of taking the actions of doing mathematics, we know that inherently, in order to make wise choices, wise decisions, when we engage in the doing of mathematics, that requires the use of critical thought as well. And so from our last session, hopefully what you walked out of the session or left the session with was an understanding that quality thinking in mathematics requires mathematical decision making that is sound and effective, that only takes place through careful thought. And in other words, careful thought that requires the consideration of relevant mathematical options that are available, that are assessed using mathematical criteria, the gathering of mathematical evidence that is relevant, using conceptual, procedural, and algorithmic background, and pulling all of that together in order to make sound mathematical decisions. So that's kind of a summary of where we were at last time. And what we're going to be doing today, or this evening, is taking a look at responding to the following question. And remember last time I said to you that as a facilitator of critical thinking, I don't start with an agenda and tell you what it is important for you to learn and understand. I frame and invite you to think about a question and give you a way for you to think about that question, a context and a task through which you can think about that question. And so today, the question we're going to be focusing in on to kind of drive our thinking is, what are the essential tools needed to ensure that the acts of doing mathematics, in other words, the mathematical processes, are taken with critical thought, so that we actually have proficient use of those processes. And the task we're going to be doing is thinking about assessing how important it is that the intellectual tools of effective critical thinkers should be critically thought. So as a sub-question to the bigger question, we're going to be looking at, do the intellectual tools of an effective critical thinker support quality acts of doing mathematics? In other words, do they support proficient use of the mathematical processes? And to get us to actually see whether we believe they do, or to see whether there's enough of them to support that type of mathematics in action, if I can say it in a more concise way, we're going to be taking a look at each of the tools, and we're going to be considering, well, not necessarily looking at each of the tools, but looking at each of the mathematical processes and looking at the tools within the mathematical processes and asking, how important are these tools for us or for our students to be quality mathematical thinkers? Again, to set this up so that we want to always start off with where your thinking is at the very beginning. And remember, last time I spoke about how important it is to really launch the learning in your classroom by inviting your students, inviting your learners to enter the learning process where their background knowledge and their skills begin with them. So we want to allow them to access the learning process where they are at. And I want to do the same thing with you this evening. So I'm offering you this particular launch. And in this particular launch, I'm going to, it looks like you can't really see the top part of the page here. So I'm going to be asking you to consider how each of the following intellectual tools of an effective critical thinker might play an important role in the support of the proficient use of the mathematical processes. I'm going to very quickly walk you through each of these tools. The work of the Critical Thinking Consortium is based on the foundation of research and work that has been done that says that for our students to become quality critical thinkers, they require 5 intellectual tools. And those 5 intellectual tools are background knowledge, criteria for judgment, critical thinking vocabulary, thinking strategies, and habits of mind. Now, we spoke at length last time, and I think most teachers of mathematics understand the importance of background knowledge. And when we talk about background knowledge in mathematics, what we talk about is the procedural, algorithmic, and conceptual knowledge that students bring into the learning. So when I'm going to be speaking about background knowledge, that's what I'm talking about. You saw last time examples of criteria for judgment that students use. In other words, as students are engaged in mathematical decision making, what criteria do they use to help them make quality mathematical decisions? So we're going to be thinking about that as an intellectual tool. We're also going to be thinking about critical thinking vocabulary. And critical thinking vocabulary does not mean, it's often confused by math teachers as discipline-specific vocabulary, mathematical vocabulary, although that's important, and we will talk about that. Critical thinking vocabulary is the vocabulary of mathematics that is asking our students or inviting our students to think mathematically. So for example, when we ask them to make a conjecture, do they understand what the word conjecture means? When we ask them to make an estimate, do they understand what the word estimate means? When we ask them to compare, do they understand what the word compare means in a mathematical context. When we ask them to rank in order, do they understand what rank in order means in a mathematical context? So that's what we mean by critical thinking vocabulary. The fourth intellectual tool is a thinking strategy, and a thinking strategy is what students need to use in order to organize their thinking so that they can make effective mathematical decisions. And then lastly, there's the habits of mind, which many teachers, when I talk to teachers about what makes a student successful in mathematics, one of the first things they talk about is habits of mind. And what I've put here in brackets as examples is the habits of mind that the research says is most important or most significant to student success in mathematics. So I've highlighted paying attention to detail, perseverance, being flexible-minded, and being open-minded. And because those are the ones that the research highly supports as being the habits of mind that our students need to possess in order to be successful in our math classrooms. So what I want to do is invite you to take 2 minutes just to pause, and along the ranking line that I've offered you here is take a look at each of those intellectual tools, and based on your current background knowledge and experience with your students in the classroom, take some time and decide how important do you think each of these intellectual tools are to the successful use of the mathematical processes by your students in the classroom. And if you can use your tools in your toolbar to either place a check mark or an X along each of these lines so that we can see what your thinking is at the beginning, it would be really helpful for you to do that. So I'd like to give you 2 minutes, spend some time, and if Michelle maybe can put the timer on, you can identify, looking at each of the tools, where do you stand right now? What's your position with respect to the importance of the role of each of these tools in mathematics? And in particularly in the light of the use of the mathematical processes. I'd like to thank everyone for sharing their positions. It's really nice to see that there are check marks in relation to each of the tools, and that although there are check marks that are leaning towards the left side, there's kind of a cluster, that there's a range around that area, which shows that there are some varying degrees of positions from the people in the group and their thoughts around the importance that the role of each of these play. So this is a great starting point, and what I'm going to do now is, having put that down and giving that showing that as a starting place for us to begin, I'd like to now begin with having us explore each of the mathematical processes in the context of some mathematical tasks and questions that students in grades, probably focusing more grades 7 to 9 with the group. But what I'm going to do is highlight each of the mathematical processes one at a time and talk to you a little bit about these tasks and get you to think about, again, those intellectual tools. And I'm going to have you going back to that particular chart and seeing if your thinking changes at all along the way once we've looked at some examples. So here's an example, and this is actually a grade 8 example that we've used in the classroom. And in this example, the students were actually, I'm going to contextualize it a little bit, the students were asked as a driving question and task. They were asked to create winter wonderland projections that the principal in the school was going to project in the front hallway during the winter season in order to kind of make people feel a little bit more cheery during a season that generally people tend to feel is a very long season and it drags for a while, and people tend to feel dreary over a period of time. And basically the students were asked to use geometric shapes to create an image that they were going to project on the wall using a standard projector. And that image was to project some kind of winter theme. And in order to help guide their thinking, they started to consider a particular shape, a particular design, and that particular design involved triangles. And they started by looking at, and that design was broken down into 2 different sets of triangles. So this first set of triangles was part of that image, and then these triangles were inverted, and that was the second part of that image. And what was nice about the image is the students saw that they could use triangles, a very simple shape, and actually create an image that looked like it was coming off the page. So it was interesting for them to consider. With that context in mind, then the students were asked, how similar is the blue triangle in this image to the group triangle that they were assigned? So you'll notice that each of these triangles, including the blue triangle itself, was assigned to a group, and the group was asked to compare the degree to which the triangles were related. And they were asked, based on similarity, that they think that their triangle was very similar, somewhat similar, or a little similar to the blue triangle. And in doing that, they started off the way I started off with you, with a launch, and the students were asked to think about, so what are your initial positions? And as they took an initial position, they didn't have any criteria to begin with, but as they took their initial position, the students were then given an opportunity to ask some questions, and then were asked, so what were you thinking about as you were doing this comparison, as you were considering how similar the triangles were? As a result, the students surfaced criteria for degree of similarity, and they talked about that it was important that they not only considered the number of mathematical features that were shared by the triangles, but that they also considered the nature of the features. And so they started to surface the nature of the features. So what are some of the things that you were looking at? And some of the things that the students began to consider when they had time to think individually, they surfaced looking at the lines, looking at the length of the lines, looking at the area of the figures, looking at a number of different things. And they also talked about you know, when I compared these different things, how regular was the nature? So were there any patterns or trends that came out? And they came out with the following criteria for judging the degree of similarity. And together with the teacher, they created the following thinking organizer. Now you'll notice in the thinking organizer, a number of the different things they talked about were placed in the organizer to help them gather mathematical evidence in order to support their judgment. So they put in angles, side lengths, orientations, area, perimeter, and eventually, by the way, not initially, but eventually they also wanted to add the orientations of the lines. So what lines were parallel, what lines were perpendicular. This made for some very, very interesting discussion, and the students then, from this point, engaged in some collaborative sharing. So in their sharing, to get back to the criteria, if I move back to this criteria, the students then not only looked at the number of the different mathematical features that were considered, that were shared and similar, but they also considered the nature of the mathematical features, and they themselves said, well, how do I figure out whether there was regularity? And that's when they noticed the importance of being able to collaborate and share their results and look for patterns and trends. So the reason for their consolidation at the end was one that was very purposeful and intentional, and it was purposeful and intentional because they identified initially the importance of, through the criteria, the importance of identifying regularity. Okay. So I want you to pause at this point and see if you have any questions that you'd like to put in the chat box. Are there any questions that you have, questions of clarity? Are there any concerns that you see that might be raised by this? Or is there anything that you're seeing as opportunities for students, learning opportunities for students, as you look at this particular challenge and how it connects to reasoning and proving? And I want to give you a moment just to see if you have any ideas. And if you don't have any questions or anything that you're wondering about or concerns, what I'm going to ask you to do is, if everything's perfectly clear and you're ready to move on, can you show me a smiley face? And if you're feeling a little bit confused, can you show me a confusion face? I'm seeing some happy faces, which is good. How's the rest of my group doing? And please don't feel shy to show me, oh, there's a confused face. So thank you very much for sharing that. That's really important. Can I ask, for those of you who are feeling confused, what question might you ask me so I can help to clarify? And if you want to put that question in the chat box, that would be very helpful. Thanks, Chris. That's very honest. Perhaps there might be more clarity, as what I'm going to do is move on, because I'm going to continue with this particular task, and maybe it'll be helpful to take a look at the next part of this task to help clarify some things. But before we do that, what I'd like to do is just very quickly, again, highlighting some important features as the students were considering the similarities between the various triangles here. And I want to highlight one important caveat that I had a teacher ask me about. They said similarity is an important math concept, and it means something very specific. And here we're asking in a very casual way, can you tell me how these triangles are similar? So I wasn't starting from the context of do you understand what the concept of similarity means, and can you use that concept? I just asked them in a very simple way, can you identify the similarities between these different triangles? And I think the teacher's concern was an interesting one, but what was important and what the teacher realized and what the students realized as they actually did their thinking and charted out all of their evidence. So as they compared their triangles, they compared the angles of the triangles, the side lengths of the triangles, the orientation of the vertices, the areas, the perimeters. As they did all of that, what they began to realize is that even a triangle like the one that's in the middle that is congruent is also an example of a similar shape, because this is, in terms of ratios, 1-to-1 to itself. And that was really important for the students to recognize, because when we got them to the point where they began to generalize their understanding of these ideas, they were able to see that actually congruency was an example of similarity. And they didn't see it as something that was completely different. But it was an excellent question that was asked. Chris, I'm wondering, do you have a question? Because I see your mic is on.
Oh, no, sorry.
Oh, it's okay. Thanks. All right. So having gone through that and having gone through the thinking that the students did, what I'd like you to do again is pause and look at reasoning and proving. And again, going back to this, take a look at the role that background knowledge, criteria, critical thinking vocabulary, thinking strategies and organizers, and habits of mind played. But this time what I'm going to ask you to do is I'm going to ask you to think about not just how important each one was, but which do you think were the two most important in having the students successfully reason their way through answering and responding to this question. So as you engage in reasoning and proving, which of the intellectual tools, which two of the intellectual tools do you think were the most important? And again, you can just put your thoughts in the chat box, or you can use your tools to identify them. And let's take about 30 seconds to do that in. Well, thank you very much. That looks like a very balanced split, but I'm looking at kind of overall, I'm seeing critical thinking, vocabulary, criteria for judgment, and background knowledge as being the ones that are highly important according to the group. Habits of mind coming in there fairly strongly. And I don't know if you noticed, what's really nice to see is that there are connections across all of these, that there is some fluidity behind the use of all these intellectual tools. So for example, as we look at the thinking organizer, and I'm just going to flip back and forth a little bit here, here the students are gathering their mathematical evidence to help them make a quality judgment or a quality decision and engage in quality reasoning. But they are also using and gathering and using their background knowledge to enable them to do this. So there's a connection between the gathering of evidence and the use of background knowledge, their conceptual and their procedural and algorithmic knowledge. So a very tight relationship between these two, and also a very tight relationship between the criteria for judgment and the thinking strategy, because they've decided to focus in on these things because this was their criteria for judging. And if they hadn't had this criteria, they wouldn't have identified all of these very detailed areas, mathematical areas, for them to be gathering evidence around. So I think what you've done is really highlighted a lot of really important ideas. And last, probably one of the things that we often talk about, and one of the things I really want to highlight that's important, is the things, the tools, the intellectual tools that as teachers we can, by providing students these types of questions and working with them to create the organizers and surface the criteria, we can teach each of these different intellectual tools. But you'll notice that we can't teach habits of mind. All we can do is nurture habits of mind. And we nurture habits of mind by doing something really important, and that's by asking a question and setting up our classroom so we're inviting. You'll notice that at the very beginning, the students were given this question and asked to decide that they think it was very similar, somewhat similar, a little similar, before they even engaged in the task. Then they identified criteria from that independent thinking as a group, and then they were able to work collaboratively to share all of their thinking in order to go back to their individual thinking and see if they had anything they wanted to change from their initial thinking. So setting up your classroom in a way that nurtures and structures the sequence of the learning opportunities really nurtures these habits of mind. So I just wanted to point that on before we moved on. All right, we're going to take a look at reflecting now, and what happens next with this particular. And Chris, you asked, did they create their organizer? Actually, what they did do, just very quickly, is they started here. And remember, individually, they kind of started to think on their own about what position they would take. And as I asked them, as you did your own individual thinking, I don't want to know what it is that, I don't want to know what your answer is. I don't want to know, but I want to know, what is it that you were thinking? What helped you decide whether you thought it was very similar, somewhat similar? And that's when they started to identify the criteria. And by identifying the criteria, they raised, well, I need to know the nature of those similarities. And when they identified the nature of the similarities, they started to say, well, I'm going to be looking at the angles, the side lengths, the area, the perimeter. So although as the teacher, I would have had this already prepared in my mind so that I could fill in any gaps the students would have perhaps missed, because one of the things they really didn't get to is the orientation of the vertices. And one of the things they did get to, that as a teacher I wasn't anticipating they would get to at this point, was the orientation of the lines. Were they parallel or perpendicular? The students were able to generate all of these ideas, and together we created the organizer. So they did actually collaboratively create the organizer, which was one of the nice outcomes of asking the critical thinking question. So what they did next then is moved to the reflecting stage, and they did that through verification. And again, notice that as the teacher, we really want to choreograph the learning. So what we want to do is we want to invite them to engage in reflecting. So the next question they were asked is, would it be true for a few, some, or all of the cases that the relationship between the blue triangle, the one that was in the middle, and the other triangles can be described in the following way? Now, your students are going to look at this and say, wow, that's really abstract. But what we want to do is we want to teach students to move from the very concrete to the more abstract way of representing ideas. So we want to model that for them. And we give them this particular identity, and we give them an example and show them how it works. And then we ask them And we say to them, well, it looks really convincing, doesn't it? It looks like, you know, a really expert mathematician would have put this together. And if you looked at this, what do you think? Do you think it would be true? Or do you think we need to kind of take a look at our evidence? And the students initially looked at this and they said, well, you know, it looks pretty convincing when I first look at it. But now that I see an example, I'm really curious and I want to go back to the evidence. So the students now took this and went back to their evidence chart, and they actually gathered all the evidence around the orientation of the vertices, and they started to actually test this and see if it worked in all cases. Now, it was interesting because what they did find is that, in fact, it did work for all cases, but there was a particular reason for that, and this was something that, as a teacher, we decided to not include in the particular presentation of this. This identity actually works if, and you'll notice here that what we were looking at, if you're familiar, is we were looking at dilations. But this particular identity only works if dilations occur at the center, or the center of the dilations was actually at the origin or the center of the geometric figures. So what we want to do then to push their thinking is ask them, well, what about in these cases? How similar are they? So now they start to look at dilations, and they start to recognize that dilations don't always have to happen at the center or at the origin. They can happen away from the origin but still be at the center, or they can happen away from the origin and start at perhaps one of the vertices. And so now they started to explore this particular identity in light of some new cases. And we started to talk about, well, how are we actually, if you're going to verify whether this is in fact true, how are we going to go about verifying? What do we need to consider? And so because the students actually did this with the evidence that they had gathered in their previous organizer, when we asked about what do we need to consider when we actually prove or disprove statements or findings, they started to think about some of the thoughts and ideas that they had when they were looking at the other things. So they looked at these and they said, wow, well, I need to consider a lot of different cases, because before I did consider cases, but there were only a certain set of cases. So now I've been introduced to more cases. And I need to consider the conditions of the cases. Here, the cases are different because they've now been oriented in a different place on the grid. And then I also need to consider the techniques perhaps that have been used in order to test this out. So the students then generated criteria for a sound verification. Now, what was really quite impressive by the work that they did was these criteria, and what I did was I showed the students, I said, by the way, Oxford University uses exactly the same criteria. Their words are a little bit more sophisticated, but you guys use the same criteria to make sure you've got a sound verification or sound proof in your reflecting as a university professor would use with his students at a university level. So imagine what these grade 8 students felt like when they actually were able to come up with these ideas through their experiences. Again, I'd like to ask, do you have any thoughts, ideas, concerns, questions at this point? If everything is clear, if you'd like to put a happy face next to your name, and if you're still feeling a sense of confusion, it would be really nice to give me a sense of whether you're feeling a sense of confusion. Okay, and seeing a few happy faces. So I'm noticing, Liz, you're saying that they can use the criteria, but perhaps miss some crucial understandings. Can you expand on that a little bit more? What crucial understanding do you think they may have missed in engaging in this type of thinking? And no worries about arriving late. I understand completely for anybody who's just been able to join us. And Liz, if you want to turn on your mic and just jump in, please feel free to do that. Okay, I'm noticing that some people are writing. As you write, okay, so if they've worked with criteria, it's more structural in nature. Liz, is your mic not working? I just want to check just to see, because I'd love to hear from you on the mic. Oh, okay. Okay, I'm going to let Liz include some in a text box about some of her ideas. And it's unfortunate that we can't get her mic working, because it would be nice to hear her thoughts about this. But hopefully, I'm trying to understand a little bit more about what it is that she's seeing. In the past, our criteria has been about let me take a look. Sorry, everyone. I'm just trying to see if I can understand what Liz is saying. Oh, in the past, we've looked at criteria about what to include in problem solving. This is really getting to criteria about their thinking. I hope that's what you're saying, Liz. I hope I'm understanding correctly. And this is a significant difference, because we are focusing on the mathematical processes, and we are focusing on the act of doing mathematics. And if you remember in our first session, if you were with us in our first session, we really highlighted how there's a very close relationship between thinking mathematically and being engaged in the act of doing the mathematical processes. So our criteria in many of these cases has to be focused on criteria that helps guide students in the thinking process, not simply about what to include or not include. In this case, you'll notice that when they use the criteria for degree of similarity, they didn't simply say, well, I looked at all the mathematical features. They looked at the nature of the mathematical features and the regularity of the mathematical features. So that requires pattern seeking, it requires generalizing, and it requires conceptual depth if you're going to be looking at the nature of mathematical features. So it's a real shift in thinking, and I hope people are seeing that. But in light of that, I'm hoping that it all makes sense, and what I'd like to do is have you now just take a look at what happened as a result of the student work. The students then, because they owned the thinking organizer as part of reflecting, the students then said, so what there are features and conditions that now we need to add to our organizer, and we have a good organizer, but maybe it's not sufficient. So it was really interesting to see that the students are continuously, as they're developing understanding, as they're thinking critically through the mathematics, and their learning is deepening at every step, they're also reframing and deepening the nature of the gathering of the evidence that they're doing, and deepening and further deepening their understanding. So it was really fascinating to see the result of what the students ended up doing. I want to be very careful and cognizant of time. So again, I'm going to bring us to the intellectual tools and the role that they play in the act of reflecting. And again, this time I'm going to ask you to just identify which intellectual tool do you think played the most important role in the act of reflecting. Let's see if we can see if there's something in particular you see that was most important. Because if we're choosing to explicitly teach each of these tools, sometimes when we take a look at each of the mathematical processes, we have to target very specific things. So if you were doing this and you wanted to target an intellectual tool that you were going to teach and be very explicit about with your students, which one would it be? And again, let's take 30 seconds and just see what everybody's thoughts are. Okay, thank you very much for sharing. It's great to see. I'm actually fascinated to see that there are no check marks in the background knowledge, and I'm thrilled to see that, because really one of the things that I want to encourage teachers to see is that when we engage students in mathematical thinking, what happens is that students think to learn as they learn to think. And these two things happen simultaneously, and that background knowledge is constructed, and they become more proficient at the background knowledge through the thinking process. It's one of the ways that I like to define a balanced approach in mathematics. I know there's been quite a bit of discussion around that. What does a balanced approach to mathematics look like? And to me, a balanced approach to mathematics means that both the development of proficient background knowledge and of proficient mathematical thinking is happening simultaneously, not at two separate times in a disconnected, disjointed way. So it's really nice to see that you know, most of the check marks are actually straying away from that, because that's a true reflection of what our work really has shown over the last few years as we've worked in schools with students. Chris, you've asked a question about how do we assess thinking and the quality of thinking, and that is what we're going to talk about in our third session. So I'm glad that you raised that question, but we will definitely be taking a look at that. I want to move on to the next example, and I just want to give you a few minutes just to read this question, because I'd like to give you some time to actually try this out. It's really powerful, but I want to just give you 30 seconds, read this question, and I will give you some context about it in a minute. Okay, so hopefully you've had an opportunity to read the question. You have a general idea of what is going on. Basically, just as a summary, there's a small town, population of children has increased from 4,000 to 8,000. There's a community swimming pool. The town would like the community swimming pool to hold the capacity of the increased number of children in the community. So they're asking, can you increase the size of that swimming pool? But there are 4 endangered species trees that were planted when the pool was constructed, and the town saying, well, we really don't want to, they're endangered, so we really don't want to remove them. And the question is, can we do something to meet the increased capacity? And we start off by, again, offering the students a lunch. And we ask, what would you recommend the town council do? And they have 2 options: nothing because, and they've got the visual, or change the pool so it looks like this because. And what I'd like to do is give you 2 minutes to think about how would you respond to the question. If you were in the shoes of the students, what would you do? Hopefully you have a piece of paper with you somewhere where you can actually physically take a stab at doing this, because it's important. I'm glad you're asking questions. This is very good. So did the pool have to be a specific shape? Great. If there's anybody else with other questions, please put them in the chat box. Okay, are there other restrictions besides the trees? Another excellent question. Great question. Can they simply build a second pool? So that's a question. The students often ask that, and the students say, well, can they build a second pool? Can we move the pool someplace else and make it as big as we have space for? And one of the things that we say to the students is, and this is important, is we have them, okay, let's read the question. What's the question saying? And let's stick to the parameters within the question. There's an existing pool, and we want to know, if we went back to the question, and I know for you, I didn't let you see the question for a long time. You only saw the question for a short period of time, and it hasn't been sitting in front of you. But you can see here that they're faced with a dilemma because they want to see if they can afford to make the pool larger. Right? So the actual question, and this is a real challenge that we have with children too, is how do you stick to the question and the constraints of the question? So I think it's a great question. It really highlights some of the struggles that we have with our questions. Okay. So does it have to be in that location? Great, that too, similar type of question. So the students, just like you have, start to raise a bunch of questions, and these are the questions that they typically ask, which is very interesting. How large does a new pool have to be? I think that all of you, when you read the question, because you have the mathematical proficiency, didn't have that as a question that you would ask. Some students might still be stuck just with that particular part of the question. But for you, you probably said, oh, the population, doubled, so, it's just logical that we want to double the size of the pool. But that's a question the students have. How large does a new pool have to be? What shape can the new pool take? What position can this new pool take? Can it be moved somewhere else? Or can it take a new position where it's at and where it's actually positioned right now? So a question about orientation and what happens to the trees. So they ask a little bit more about the trees. Now what's fascinating, as we take the time to start talking a little bit more about these questions, the beauty of the questions they come up with from the launch is that they co-construct criteria. And they start off with the following criteria. That they decide, based on the information from the question, that, and they all agree on, they come to a shared understanding that the pool needs to be twice the size of the old pool. They also agree that the pool needs to take on the shape of the old pool, or it needs to build on the shape of the pool, because they look at the context of the question and they're saying, oh, the town just really wants to enlarge the existing pool. So this is the essence of the problem if we read it really carefully. And the third criteria is they want to protect the trees. So given the criteria, the students then get a second shot at doing this. And then what we do is we start engaging in some thinking and some teaching. Now, the teaching that we move to is transformations. And we ask the students, would considering transformations be helpful? And then we ask them, so what are the possible transformations? And at this point, this was a grade 7 task. At this point, the students were coming in with background knowledge around translations, reflections, and I think that's possibly, I can't remember if it was rotations as well, but they were coming in with some good background around translations and reflections. Rotations too, thank you very much. And so they could list those as options. Then as a teacher, I could say, well, you know, there is such thing as a dilation, and I'm going to put that on the list because it's an option that we might want to consider. And then what the students do is, in light of the criteria, they explore each of the transformations. And so at this point, they've already considered translations, and that's going to be a bit of a review. They've considered reflections, that's going to be a bit of a review. Now they look at rotations, and they're asked to complete the same task with each of the different types of transformations. What do all of these transformations have in common? And they do a whole lesson around this. And then they do one, I haven't put it in here, but they do one around dilations. And each time they do it, again, they've got a thinking organizer. So when they talk about what do all of these transformations have in common, they're saying, well, what are you looking at when you're deciding what they all have in common? And so the students start generating some thoughts. And we build a thinking organizer. And in the thinking organizer, they say, well, we're going to take a look at the length of the sides, the angles, the area, perimeter, and the positioning of the vertices. And in the end, as we look at all of the different shapes, we're then going to decide, well, what do they all have in common? Because again, we want to be generalizing, and we want to identify what they all have in common so that I can identify what are the properties of each of the transformations and then label the transformations. The beauty of this is they then go back and then they say for each of the transformations, they say, will this transformation, so will the transformation of a translation be helpful to solve this problem if these are my criteria? Then they take a look and do some thinking around, some critical thinking around reflections in the same way. They construct a deep understanding of reflections, and then they go back and they say, will the transformation of reflections be helpful to solve this problem? And they go back to their design and they consider their design again and see if reflections are helpful. Then they do it again with rotations, and then they do it again with dilations. And what they end up doing, and I'm not sure if I put it here, but I'm going to go back very quickly, the question that brings them all together is to decide which transformations would be most helpful. Now the beauty of this, and I'm going to give you a little bit of background on this, I actually am borrowing kind of the basic structure of this question from a University of Oxford from London, England, because when I was presenting in Switzerland in April, I was able to go to a session on my time off by this university professor, and he actually introduced this problem. And it was fascinating because when he introduced this problem, he said, well, I have this great problem that's going to promote creativity and creative thinking and innovative thinking in the math classroom. And basically what he did was he said that there's a square pool and there's these 4 trees, and he said to the kids, okay, so how am I going to double the size? He didn't set a context, but he said, I want to double the size of this pool, but I'm not going to let you, sorry, slide 16, absolutely. I'm not going to let you I'm not going to let you move the trees because the trees are they're an endangered species. And so he let the kids just kind of muck about with it. And every time the students came up with an idea, and I don't know if you're able to generate any ideas yourself, but the first thing that the students tried to do, some of them got frustrated because they thought, well, no, it can't be done. Because if I increase the size of this pool, it's always going to run into the trees. And then other students said, well, no, I can create a composite figure that can work around the trees. But every time the students came up with an idea, he simply said, well, no, you're not allowed to do that. You're not allowed to do that. You're not allowed to do that. And that really shut down the thinking of the students. And so he said that, you know, he was somewhat frustrated by the students' inability to think creatively. And when I spoke to him afterwards, I said, well, perhaps it was the way that you presented the problem to the students that limited their ability to think creatively. So I showed him how you might be able to do this and presented it this way. And I said, and the importance here is the introduction of constraints. When you're having students make connections, connections with constraints is one of the most powerful ways to encourage your students to engage in innovative creative thinking in mathematics. And so, but what's important is that we present those constraints within a context, and that students are given an opportunity to muck about with the thinking, but recognize why the thinking is limited and how they might approach it from a different way. So you'll notice here that when we now I'm introducing mathematical concepts and content that is meaningful for the students in solving this problem. And the students, when we use this, were so excited and so engaged. And it was funny because one of the things that we did is we said to them, when they started to create composite figures, we said to them, well, by the way, something, you know, it was really, really bad news, but the town council came back and they said that the water piping to the pool was designed underground such that we had to make sure that it continue to be a regular geometric figure. So we can't create composite figures. We have to, and it was so funny because the students went, oh no, that can't be possible. And we said, you know, no, but that happens in real life. Like they don't have the budget for it and the structures like that. So what are we going to do? We don't give up. We still have to solve the problem. And so the kids, they just went at it one more time again. But the beauty of it was when we introduced the new learning to them, they then saw opportunities to apply that new learning to solve the problem. And in the end, they then recognized, so they mucked about with the translations and they said, oh no, translations aren't going to help. And they mucked about with the reflections and they said, oh, the reflections aren't going to help. And then they began to realize when they got to rotations, they said, wow, if I rotate this and I dilate this to double the size, then I actually can solve the problem. And so what we then did is we said to the students, wow, what does it mean to effectively make connections? And together with the students, we constructed criteria for effective making of connections. To pay close attention to all the relevant details in the problematic situation. And the students said, well, we did that by constructing criteria. And I said, yes, you did. And that was really, really good of you. And then they said, well, and we thought about what we already knew and understood. Now here's what's important. I said to them, what you knew and understood to be mathematically true. Because what's important is that you can't make stuff up to solve the problem. It has to be mathematically sound. It has to be mathematically true. So they talked about that. And then they talked about the aha moments they had when they integrated the new mathematical knowledge and understanding that they gained. So then they said, well, we had to consider new mathematical knowledge and understanding that was relevant to the situation. And we had to continuously test, verify, and extend our thinking, that link, that connection. So they came together and they did a beautiful job at identifying criteria for effective making of connections. So again, I'm going to invite you, in light of making connections and the important link of this to encouraging students to solve problems, making connections in new ways, innovative ways, which of the tools, and I'm sure this is starting to get harder all the time, which of the tools do you think are most important in supporting the proficient use of the act of connecting? Perseverance all the way, absolutely. Paying attention to detail, the perseverance, being flexible-minded. Absolutely, I would say, out of all of the intellectual tools, nurturing the habits of mind are so essential to the act of connecting and to creative, innovative thinking in mathematics. So thank you very much for sharing that. I think although all these others are also very important, and you probably saw that they play a central role, the habits of mind are central. I want to now just very quickly talk a little bit, and I'm not going to spend more than just a minute doing this. And sorry, you wanted me to jump back to slide 17, but I'll do that in a minute, Chris. I want you to show how important all of the work that was done there with the students is for moving students to what the kind of work and thinking that they're going to do when they engage in mathematical thinking at a grade 9 level, because this is the question that the students, grade 9 students, work on. Notice how the thinking, the content, the big ideas in the math are very similar to what the students did, and I have to say that the teachers who worked with the students on the other two tasks that you just saw, these students are going to be so prepared for this type of thinking in grade 9. Here's the question that the students are focusing in on, but you'll notice that the only difference here is that they're now building in the content of the grade 9 curriculum. They're now looking at linear properties. They're looking at linear relations, which is the central concept of a lot of the work that's done in grade 9. So when we do our work in our classrooms, it's nice to be thinking about, and the beauty of using the mathematical processes is the mathematical processes ensure that we're building a continuum of competencies in our students to be successful across all of the grades. So Chris, I'm going to jump back to slide, we wanted to see slide 17 again. Did you have a question about slide 17? Okay, great, thanks. All right. Please let me know if you have a question, raise your hand. If you have a thought you'd like to share, please let me know. I want to very quickly move to communicating. Last time when we got together, we looked at communicating, but we focused on communicating through the choice of appropriate representations. This time, what I'd like to do is focus in on communicating using mathematical vocabulary and the structure of how students communicate. And I don't know how many of you are familiar. I'm going to just ask very quickly if you can put a thumbs up if you're familiar with this, or a thumbs down if you're not. How many of you might be familiar with a strategy called barrier games? You can give me a thumbs up if you are. Thumbs down if you're not, just so I can get a sense. Okay, some people are, some people aren't. Okay, fabulous thinking strategy to get your students to understand and co-construct criteria around effective communication in math. And just wanted to quickly share it with you so that we can think about that criteria around the processes of communication. And in this case, for those of you who aren't familiar, what happens here is the students are given some kind of visual representation that deals with the math content that they're doing. And there's some kind of a visual block, so the students can't see. What I like to do is I like to say to students, I know that you're going to communicate effectively in math. If you can't use body language, or you can't see what the other students are doing, that you're using the way you orally and in writing communicate with one another in as clear and as best way as possible. So I always like to start the students with a complete set of barriers to their communication. So what I have them do is they have them sit back to back, and one of the partners describes the visual. I always choose a visual that's connected to the content that they're going to be learning, and one of the partners describes the visual to the other partner. The other partner's objective is to redraw the visual as precisely as possible, as accurately as possible, to the best of their ability. So this happens, and the students, once they're done, they compare what the visual looks like to what the partner was able to reconstruct, and they talk a little bit about what went well and what challenges they face. And then this happens again a second time, and now the second partner does the describing to the other partner, and the other partner does the reconstructing or the redrawing. And after they've done that, again, they compare, and they talk a little bit about, so what went better and what continued to work. And then together as a whole class, the students talk about, so what was effective? What helped you communicate really, really well? And I've done this so many times for a number of reasons. One is the students love it. The engagement level is really, really high. Two, it gives me wonderful diagnostic data, evidence around what my students already understand around the content that I'm going to be teaching, what vocabulary they already possess. And three, it really, really hones in on the criteria for effective communication in math. And every single time I do this, and I've done this right from working with children in kindergarten to grade 12, they always come up with the same consistent set of criteria. And this is what they say. They say we needed to use a common set of vocabulary terms that are generally understood. So both partners needed to understand the vocabulary. And if the vocabulary wasn't understood, I resorted to a clear description or explanation of the vocabulary that I used, just to make sure that my partner understood what I was talking about. So central to communication, they really understood and appreciated the importance of mathematical vocabulary. They also understood the importance of not just using the vocabulary, but conceptually understanding what each of those terms meant. Because you can't describe what that term means if you don't conceptually understand what the attributes or the properties of that term or that concept is. So really, really brought home for the students the importance of those pieces. Secondly, they talked about sharing common background knowledge, and they said it's very important that you then consider who is your audience, who are you communicating with, and choosing the appropriate way to communicate so that I'm thinking about what is the background knowledge that that person is bringing into this, my reader is bringing into this, so that I can communicate clearly and so that everybody understands what it is that I'm saying. They talk about the use of questioning for clarification, but only if the conditions permit. Then they also talk about, and this is really, really nice, that they need to have a clear logical development of ideas. And so if we go back to the visuals, for example, in this case, the students will say, well, I either started at the top and worked downwards, or I started at the bottom and worked up. But everything needed to start somewhere and be clearly connected and sequenced in a way that made logical sense. So they really understood the importance of that criteria. And lastly, what really, really makes the consideration of context important, and the importance of context in mathematics so key, is every single time they talk about, well, it really helped to give a context. So for example, when I looked at this visual, I said, well, imagine a person juggling balls into a tin. Or they said, imagine that this is going to look like a flower. So it was important for them to be able to portray a broader context. And the student said, so when I'm learning something or I'm communicating something, I really need to think about, what is that really important math idea? What's that big idea? What's the general idea I'm trying to get across? And nothing excites me more as a math educator to hear my own students saying that these are the important pieces. So a really powerful strategy that gets to the building of vocabulary, how to organize how you're going to communicate, gets to a lot of the really, really important attributes of communication for it to be successful, and all through a really fun thinking activity that gets students to actually construct through experience for themselves these criteria. So if you haven't ever had a chance to do this, take the opportunity. By the way, I show teachers all the time. You want them then to practice. You can then take what they've done through the building of the vocabulary and have them extend their use and practice the use of the criteria. So in this case, they then had a task that they completed connected to the curriculum that had them using the vocabulary and practiced the use of effective communication in math. And you can see here that this strategy works in any mathematical context that requires paying attention to detail, that requires students coming up with a description, and requires students to use their understanding of the mathematics that they're going to be learning. So very flexible in use. So I'm being cognizant of the time. What I want to do again is just invite you to be thinking about the importance of each of the intellectual tools. I'm not going to pause here at this point because I want to make sure that I get through enough of the presentation with you, knowing that we have to close in about 15 minutes. But I am going to just pause for about 30 seconds and ask, do you have any questions? Is there anything that you would like to ask about the mathematical process of communication and the importance of criteria and communication, or is there any element that you noticed was missing in the criteria, perhaps that you would consider wanting to have students add to that list that you saw? I'm just going to give you 30 seconds to see if you have anything you'd like to add. Okay, I'm going to move to the last example that I'd like to share with you, and this is going to be focused on selecting tools and appropriate computational strategies. And this question I've actually just taken from the grade 9 EQAO test. The only difference in the question from EQAO and my question is that I've set a context for the students that I thought would be engaging for the students. So I put in the context of students buying Starbucks. Many of the students that I was working with in this particular class where I did this model lesson, the students were coming in with Starbucks cups when I met them, and I thought, okay, Starbucks is a great in, so this is the way I'm going to set the question. And what the students had to do here is they had to decide in answering the question, and what I really want to highlight here is that many problems and many questions, although they may appear to be simple computational questions where a student just takes a formula and they just plug in the numbers and they solve the formula. All of these types of questions, and it's interesting because I've had a lot of conversations about this, every single math question you're going to ask a student requires students to be able to make quality reasoned mathematical decisions for them to effectively answer that question. So for example, and what I like to do is show teachers that in order for a student to answer a question like this, they need to be asking themselves the following questions. So for example, in this question, they need to consider which of these formulas are most helpful in solving this problem. So what I like to do with students is give them perhaps a standard question, textbook question or a standard EQAO question, and say to them, okay, here's a standard EQAO question. What's the thinking that you need to do in order for you to successfully answer this question? Because this is not a lot of what's going on in our math classrooms. And then I frame a sequence of questions instead of what we traditionally see in a textbook. Is here's a question, and step 1, this is what I want you to do first to answer the question. Step 2, this is what I want you to do next to answer the question. Step 3, this is what I want you to do next to answer the question. Instead of telling them what they need to do, I want to be giving them questions that guide them through the thinking that they need to do. In other words, I scaffold the process by scaffolding the thinking for them, by asking them thinking questions. So in this case, the question the students were asked is which of these formulas are most helpful in solving the problem? And on EQAO, the students are actually given all of these formulas. They're given a formula, what we call a formula cheat sheet, so they don't have to memorize these formulas. But interestingly enough, they've been given a sheet here, and they have 4 formulas: the volume of a sphere, the volume of a cylinder, the surface area of a cylinder, and the surface area of a sphere. But then when they're looking at the actual cup, you'll notice that this cup is not either a sphere nor is it a cylinder on its own. So the students need to be making some decisions. And so when the students start to think about, well, how am I going to answer that question, the really important piece for them in helping them to decide was coming up with the criteria for selecting the most appropriate computational strategy. In other words, what's the most appropriate formula? And when they thought about how am I going to choose 1, 2, 3, or 4, or do I have to do something differently, I need to be thinking about what fits with what is mathematically true about what I'm being asked to solve. So I've been given information about volume, and I've been given information about surface area. So what do I know about those things? And what fits with the relevant evidence in the problem? So they need to be thinking about, so this is what's in the problem, this is what's been given to me, this is what I know is mathematically true. How do I use that in order to decide what's most helpful to solve the problem? So what they did then is, again, and in this case, for these students, I actually offered them the thinking template. And I said, the thinking template really walks you through the process, the critical thinking process. So you have 4 formula options, 1, 2, 3, 4. What do each of the formulas tell you? What's the information that the formulas provide you? So what's your mathematical understanding of the formula? How does each of the formulae fit with the evidence in the problem? And as a result, is it helpful or not helpful? So this was the scaffolding thinking that the students need to do to recognize that, well, yes, you've given me all these different formulas, but none of these formulas on their own are going to help me solve this problem. Now, what happens in grade 9 when the students actually see this on EQAO is they immediately just jump to one of these formulas and try to plug in the values that they have here to make it work. They don't actually think about what it is that they need to do with the formula to make sure that they've actually constructed a different formula that makes it work. So they need to be wondering about and scrutinizing the information and saying, if I see all the evidence I have in the problem, and this is what I know is mathematically true that you're telling me, do the 2 things fit? Is this helpful, or do I need to change the formula so that I make it fit? Okay. So again, the students are required to engage in some really quality decision making in order for them to solve a problem that seems pretty algorithmic on the surface. But it requires a lot of deep conceptual understanding, and it requires them to understand, to do some deep thinking in order for them to solve the problem. So again, we can see that each of the 5 intellectual tools plays an important role, even in the proficient use of tools and computational strategies. The final task that I have is around representing. So what I'd like to do here is offer you 30 seconds just to take a look at this task. And the task is asking the students, what is the best way to represent this pattern of seating arrangements? So they've got 5 options. They've got 5 options to consider. I'd like to ask, what do you notice about the 5 options? Is there anything that pops out at you when you consider the 5 options? You can put your ideas in the chat box. Okay, they're all connected somehow. Yeah. Okay, there's something that students can connect to, hopefully within one or some of these options. So there should be a starting point. It gives them a choice to consider, so they can consider another option if they can think of another one. Absolutely. So what we want them to do now is, so how do I decide what's the best way to represent this pattern? So students then, how are they going to decide the best way? Right, the option depends on what you want to do, the representation. So what you're getting to, Danielle, is really good, is you're getting to what the students start asking is, I need some criteria. Okay, I need some criteria to help me judge what's the best way. And really, I use best way because that's accessible language to students, but then in an additive way, I say, well, best way is really what's the most appropriate representation. But you'll notice here that the criteria that they really need to be considered here is the representation informative? Does it accurately, with the necessary precision and details, communicate the mathematical idea intended? Is it simply eloquent? In other words, does it fluently and persuasively communicate the intended mathematical idea in the simplest way? Teachers like to say efficiency, but I don't think efficiency really captures the depth of what it is that we really want our students to be doing when they choose a representation. We do want simplicity, but we don't want to lose the richness of the idea that they're communicating in the simplicity. So we want simple eloquence. And then lastly, we want it to fit with the context and the situation. And we want to offer the students a thinking strategy. So notice that what I've done here is I've just used a traditional mind map, and I've put a question based on each of the criteria in the center of the mind map. How informative is each representation? And we put in what is informative, and the students, we have a conversation with the students, and generally this is co-constructed with the students and put in their own language. But what is informative about each representation? And they look at each representation and know what they do. Okay. Notice that what they do is they assess each of the representations for how informative it is. And then they assess each representation about how simple and eloquent it is. And then they assess each of the representations about how well it fits the context. Once they have assessed each one, they're then better able to make a holistic judgment. Now, Chris, you asked a question about is simple eloquence the same as elegance? The idea of eloquence means that it is persuasive and fluent, so that when someone reads something that's eloquent, it flows really, really nicely, so there are no bumps in the ideas that are being communicated, and there's an element of it being able to convince. And that's really what we want our students to be doing in mathematics, is as you communicate through something, I want to see an element of an ability to convince me that this is the mathematical idea, that the mathematical idea is so clear that there's a convincing element to it. Okay, so thank you very much for the question. Absolutely, it is. I guess it might be very, very similar to the idea of elegance in science. Thank you for sharing that. So that then brings us to problem solving, and what I'd like to do, and my intention around problem solving, is to use problem solving in our third session to connect it to to have us thinking about how is problem solving, what are its similarities and differences to the other mathematical processes. So which mathematical processes does problem solving most resemble? Because that's going to help us come up with the criteria. And then I'd like to use that one to bring us to the assessment piece in our third session. So I'm going to leave this one here for now, and I'm noticing it's around 9 o'clock at this point, and we also want to close. But before we close, what I really would like to do is end with this particular question for you, because this is where we started. We talked about whether the intellectual tools of an effective critical thinker support the proficient use of mathematical processes. So I would like to ask you two questions. One, if you can put a check mark or a happy face in one of the boxes. So what do you think about the role of the intellectual tools in teaching quality use of the mathematical processes, and in other words, quality thinking in math? And then the second question I'd like to ask you before you leave, once you've put your position here on the page, is I'd like to ask you to tell me how useful did you find this session? And if there's any feedback that you'd like to provide me, that would be very, very helpful. So how useful did you find the session? If you can kind of, show me a happy face if you found it very useful, or if you show me a sad face. And please, I find any useful and any feedback very, very helpful. So I really do appreciate it. So I'm seeing a lot of connections and a lot of use of the intellectual tools. Well, as you're providing feedback, and if you can, even by a happy face or a sad face or something in the chat box, would be deeply appreciated. Just want to remind you that our next session together is taking place May 18th, and we are going to be focusing on assessing critical thinking through the processes. So I know, Chris, you raised whether we were going to get to the assessment piece, and we definitely are. That's going to be the focus of our third session, and we're going to take a closer look at problem solving in general as well. So thank you very much for a wonderful evening. I know it's late at night, and I know I'm getting you to think critically in mathematics, so your brains must be exhausted, but thank you for joining us. Looking forward to our next session in May. If you have any questions, please don't hesitate to send me an email. I would deeply appreciate it. Thank you, everyone. Thank you for your feedback, and have a wonderful evening.
Thank you so much for sharing your enthusiasm and expertise with us, Laura. It was a fantastic session. I also want to thank all of you for being such incredibly motivated participants and dedicated teachers. This was certainly an intellectually challenging session, at least from my humble perspective. Before we conclude this session, I would like to give you all a few additional pieces of information. We have a number of exciting sessions related to mathematics in the coming day. Laura, your microphone is still on, so if you just want to click on the talk button.
I apologize.
I just don't want to, yeah, thanks. No worry, it's no problem. So I just want to tell everyone here that we have a number of exciting sessions and quite a few that are related to mathematics in the coming day. I moderated for Crystal Lake a few weeks ago and found her presentation extremely interesting, and she's presenting again on April 14. We also have 2 upcoming sessions on game-based learning next week, all pretty exciting topics. I'm sure that you would all agree. And also, you would want to miss Laura's next presentation, which is the part 3, which is scheduled for May 18. Remember also to visit our calendar page to learn about other sessions, and please try to encourage your colleagues to register. We also encourage you to visit our resource page with all past presentations. Bonne nouvelle aussi pour nos collègues francophones, nous avons également quelques sessions en français planifiées pour les prochains mois. La session de Suzanne Forrester sera principalement en français, mais bien entendu les interventions et questions en anglais sont toujours bienvenues. Pour le moment, les sessions de juin ne sont pas encore planifiées et pour plus de détails, veuillez donc consulter notre calendrier sur le site de la FEO, dans 2 ou 3 semaines. Je vais maintenant, I'm going to post now the links into the chat box for our calendar and resource pages if you want to access them. I also would like to tell you about another opportunity. Let me load the next slide. It's provided by OTF and the Ministry of Education. If you are a qualified teacher and completed an additional qualification course in math or technology, you may be eligible for a $450 subsidy. The link is posted here on the slide, and I'm going to post it also for you in the chat box. So if you just go to this link, you will find all the information you need to apply for that $450 credit subsidy. We also would like to present you with an opportunity to give us your feedback on tonight's session and fill a short online questionnaire. The survey takes only a few minutes. If you could do it right after the session, it would be greatly appreciated. You should be redirected automatically to the survey page when quitting Blackboard. And I'll also post that link in the chat box if it's easier for you to just pick it up from the chat box. Here it is. The survey is very important to us. We listen carefully to your feedback and pass it to our facilitators. As Laura indicated, it's very important for them to get your feedback and to know how they can improve, what you like, etc., etc. It also helps us with the funding of future OTF Connects programs, so please, if you can, fill up that survey. As a new feature of our webinars, OTF would like to offer you a small bonus as a token of appreciation for your participation. Once you have completed the feedback questionnaire, the feedback survey, you will be redirected to another page, allowing you to enter your name, and you will then receive a certificate of participation to this training session, and you can then add that certificate to your professional learning resume. Please note that the certificate of participation is only available for 48 hours. So, best would be to do it tonight or tomorrow. But if you don't have the time to complete the survey right now, or if you have missed anything tonight, don't worry, we will send you tomorrow morning a follow-up email with a link to this recorded session, the feedback survey, and archived presentation. And I'm going also to paste in the into the chat box the resource page for tonight's session. So that's Laura's presentation tonight. I will now end the recording of the session. All feel free to remain online if you wish to ask Laura additional questions once the recording is ended. Otherwise, I wish you all a very good evening, and thank you once again for your participation in tonight's session, and we certainly hope to see you soon on OTF Connects. Thanks so much.